Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. Welcome to Concurrent Programming. In this module, we'll be studying about concurrent object-oriented programming and examples, ways of doing multi-threading, and learning a lot about what is generally concurrent programming is about. So it has 4 general chapters which we will come to, and this module assumes several other things as well, including past experiences of your programming skills. So let's go ahead and discuss a little bit more about what this module is about and how we can learn more about this. Okay, so the textbook that has been designed for this module is actually this that you see on the left here. It's a little bit old book, but the content is quite okay, quite good. You can still study several things about concurrent programming, and the module is called Concurrent Programming, and the examples that have been taught will be done in Java programming. So in your first years, for example, you may have taken Java programming basics, just general assignments may have taught you several things about Java. However, you should have quite a good amount of Java in order for you to understand the coding that we are going to do. So it's both a theoretical as well as a practical module, because you are going to do several examples in order to show that multi-threading or concurrent programming can actually be shown in examples we do. Okay, so we will cover first chapter in the first week, or probably we will start the second chapter as well in the first week. It depends on how fast we go. This module has the first chapter which covers these topics that you see on the right. So we have concurrent object-oriented programming, and under it we have using concurrency, constructs, objects and concurrency, design forces, and before and after patterns. These are the 4 subtopics that we will cover in this chapter. So based on the number of classes and number of sessions we are able to conduct, we may actually be able to cover them in week 1, or we may even start chapter 2 in week 1, as I said. It has 84 contact hours, which means this is a huge module. Actually the content is quite a lot, so you really need to have to focus a lot in order to make sure you actually design the content in a way you really summarize them and easily remember them in some kind of a mind map or some kind of a revision format which you allows you to look at the content and just understand it without having to memorize much. Okay, so the module has a lot of theoretical concept as well. Okay, right, so this module assumes something, and that is you are an experienced developer familiar with object oriented programming. That is an assumption, a prerequisite. Okay, so if you haven't done any programming in Java and you are coming to this program, this module, definitely this is not the module for you. You must have taken Java as a programming before you attend this module. If you haven't done that, you should inform me, you should inform the college, and you should really go back and study Java before coming to this module. Otherwise you will never be able to understand simple things that is happening in these modules. The examples that have been created will be too complex for you to try because you haven't done any object-oriented programming yourself, so I really enforce you on that point. Okay, so Java concurrency constructs that this specific textbook covers will be about exclusions, state dependence, and threads. Basically these are the next 4 chapters that we will be studying in details as per the textbook, and we will follow them in the future weeks, and all of them are going to have several example Java implementations which we have to look through and implement ourselves. And your assignment basically is divided into 2 parts, which is assignment 1, assignment 2. In the assignment 1 you will do few exercises related to multi-threading in Java, and it will not be that difficult, it will be simple. But assignment 2 you have to do quite an extensive effort, where you'll have to do coding as well as a lot of theoretical learning to answer the questions that have been given to you in the assignment. Okay, so what is this section, this lecture about? We will be covering more about what the concurrency constructs are about, the basics of concurrency, and basically introducing ourselves into the concept of concurrency. Right, so you are going to see some of the terms when you walk through these modules, and future on you are going to see more terminologies. So here are some terminologies, some concurrency terminologies, related terminologies you have to study and learn a little bit, search around and read a little bit. So what is concurrency? How does it differ from parallelism? What is atomicity? how do you synchronize things, what is the meaning of synchronization, and threads, what is thread, what is locks, how are they used, and also what does it mean to say multi-threading. Little bit of history on concurrency. We can say, for example, before operating systems or older operating systems, you could say even a computer executed a single program from start to finish. In terms of those systems that doesn't really had an operating system, they really worked on a simple manual switches where you had a program where you start to finish is a single event or single program. But running a single program at a time is an insufficient ways of using a computer hardware, as you would agree, because a computer hardware can do multiple things at the same time. So the software, the processes, the operating system has to be modified in a way it can handle multiple processes at the same time, and it can happen at different levels. In this case, we are talking about the occurrence of multi-threading or concurrency in operating systems. So therefore, all modern operating systems run multiple programs in separate processes, of course. So inside those processes, you have several threads which communicates and executes. So this specific module, we are going to do programs that simulate processes, that simulate threads. However, you should also understand that actually threads and processes exist in operating system level as well. Okay, some of the factors that define when you are running multiple processes together are the resource utilization. For example, while one program waits for input output, why not let another program run and avoid wasting of CPU cycle? So this is one reason why we actually want to create multiple scenarios where multiple processes can run together, or we could concurrently run several processes at the same time. Fairness, multiple users or programs might have equal claim of computer resources. In that case, we have to prevent or avoid having single large programs hog the machine, so you have to give the resources to other processes as well. Okay, convenience, often desirable to create smaller programs that perform a single task and coordinate them. So it is much better to create a program that can create multiple programs that can create many things, so smaller programs that can perform the single task, meaning modular programs. When you have modules, it's better, it's easier, and much more easy to implement multi-threading or concurrency than to have one large program that does all the tasks. So even from a programming perspective, you understand that modulation or dividing is actually good. Okay, what does it mean then, concurrency? So concurrency is the ability of a program to execute several computations simultaneously at the same time. This can be achieved by distributing the computation over the available CPU cores available, for example, of a machine, or even over different machine within the same network. So essentially, if you use different machine, you are essentially using different CPUs. So distributing the computation is the key here. That is the way you can simultaneously do some work, right? Okay, now a thread itself is represented as a part of a process. So for example, what is a thread? If someone asks you, this may be, you can say, a program may consist of many tasks that can run concurrently. A thread is the flow of execution from beginning to end of a task. It provides the mechanism for running a task. So the thread defines how the task runs. With Java, you can launch multiple threads from a program concurrently. These threads can be executed simultaneously in a multiprocessor system. If you look at this example for here, if you have many threads, they can run simultaneously in this left case, in the case 8A, where you can see there is a multi-threaded system with multiple CPUs. If you have one CPU, of course, then the threads will share the time from the single CPU or from the single core. Okay, so why do we want to learn about multi-threading, and why do we want to use multi-threading? Not just multi-threading, you have to understand sometimes we can use concurrency and multi-threading in exchange as synonyms. Basically, concurrent systems is the concept here. Okay, in single processor systems, the multiple threads share the CPU time, known as time sharing. As you have seen just now here on the right, they share the time. This arrangement is practical because most of the time the CPU is idle, so they can share the CPU. It does nothing, for example, while waiting for user to enter data or input from the user. So you could actually share the CPU with other processes, and then that way it becomes more faster and more efficient. Multi-threading can make your program more responsive and more interactive, as well as enhance the performance of your application. For example, a good word processor lets you print or save a file while you are typing. In some cases, multi-threaded programs run faster than single-thread programs or even a single-process systems. So these are things you have to include if you are asking the exam or in an assignment about these questions. Why should we deploy or use multi-threading or concurrency? What is the point of having concurrent systems? You can create additional threads to run concurrent tasks in a program. So you could actually always create new tasks. If you use a program that you are controlling, you can create more threads, for example. And Java, each task is an instance of a runnable interface. There is an interface called runnable in Java, which is an interface, and I'm sure if you have taken Java previously, you will know what is an interface. Not a user interface, not a UI, not a GUI, an interface. The concept of Java interfaces having those abstract methods, So runnable interface is where you are actually going to create and enable this threading. That is the runnable object. A thread is essentially an object that facilitates the execution of a task. So we'll see this from some examples actually. Okay, so what is the difference between processes and threads? The difference between processes and threads, they are different actually in terms of granularity. A process is an execution environment provided by the operating system that has its own set of private resources, like it has its own memory, open files and etc. So threads, in contrast to the process, is the threads actually live within a process and they share resources like memory and open file with other threads of other processes. So many threads could actually talk to each other and they could share resources, and that means the process itself is divided into several different threads actually. The ability to share resources between different threads makes thread more suitable for tasks where performance is a significant requirement. Because the threads are able to share resources, it makes them a good environment for performance. So you have to remember these points in these kind of questions. That's the basic point here. Okay, so coming to a little bit of practical implementation of these things on Java, for example, because we have to simulate and understand this in a practical sense. So a task is created using this runnable interface. If you look at this example coding here, a task class must implement the runnable interface. So you have this interface called runnable, and if you have taken Java 1 again, implements actually refers to implementing an interface. If you remember in inheritance, for example, we say extends. So similar to that, we have implements when you have interfaces, features to be extended. It's actually extension of features, but you actually do that by implementing this. So you are implementing interfaces. You need to implement this method, to tell the system how to show your thread is going to run. So because you are implementing this runnable, you'll be forced to implement a method called run. See here, if you implement runnable, it will force you to implement runnable, because that's the whole point of having interfaces. You need to implement this method. You have to implement this method, meaning you have a task and the run method will say how the task will work, what the task does actually. Okay, so on the main class, for example, or if you have some other method that is going to execute this, let's assume that you have a process that's going to actually create a task or a thread. You're actually going to run a thread, and into the thread you are going to pass this runnable object. See, you are creating a task from a task class, this class which implements runnable, and here's a run method. Task is sent into a thread and the thread is started. Therefore this task begins, and what does it task do? The task does what the run method says. We'll have a look at an example. Look at this example here. We have two programs here, actually three programs here. One is on the left here, which is called print character, and this print character function, what it does is it actually prints characters x number of times. For example, here you have print character which implements runnable. As I just said, if you are implementing runnable, you have to implement run method. What does run method do? The run method finds out how many times you have to print a specific character, and then it prints that specific character. See, character to print is this method here. It assigns, sorry, this is not this method, it's a character to print. Okay, this one here, this value variable. So when you are creating a print character task, you have to give what specific item you want to print. For example, print X, print B. Look at here, for example, you have a program and main method, for example, where everything is happening. So this itself, main method itself, is a separate task, and then in it you are creating a print character object. What it does is it prints A 100 times. See, A 100 times, and then A gets assigned into which character to print. Number of times is defined by T, and therefore you have this. So once you say task.start or thread.start, which is thread 1, for example, then it will start printing A 100 times. So this is an example of a class that prints something. It's not yet implemented because when it is standalone, it doesn't work unless you create a thread and runs it. So you have this example class, and then you have another example class down here which is similar, but the difference is this one implements numbers. Okay, same thing, but it actually prints numbers. So what it does is it keeps on printing from 1 until that specific number. So if it is 100, it prints 1 to 100. For example, look at here, you have a runnable object, as I said, because you are implementing runnable. That means the print character function can be assigned inside a runnable object, and runnable is just an interface, and you are creating this object, and you are not initializing a runnable class here because this is a print character class. This is valid. If you remember, interfaces cannot be used for instantiation objects, but in this case we are actually creating a print character method and assigning it into a runnable object. You could have, of course, created a print character object itself, because that implements runnable. See, basically the idea is a thread object needs a runnable object. You see here, for example, in the previous case also, the thread is going to need a runnable object. In this case, the task itself is a task class, and this is not a runnable object, this is a task class. So similarly here also you could have created a print character class, no problem, but this is an easier way to understand that the task needs a runnable object. That's why you have here print A, print B, print 100, all of them are runnable objects, and we are creating 3 threads with them, meaning we want to run them simultaneously at the same time, and we created them using the constructors. So you should know already what is a constructor, what is a default constructor, what is an overloader constructor. So these concepts should be familiar to you. So here is a constructor, so you are sending 2 tasks. One is printing A 100 times, the other is printing B 100 times. The other is printing numbers from 1 to 100, and here it is the coding for the 2 class, 1 class, 2 class, and the output is seen here in this orange arrow. You can see here what happens is when you create threads and start them, see, these 3 threads start at the same time. So one of the things that you have to realize is in procedural programming, where you have sequence of lines, they execute one by one, and they actually wait for the other to finish. So if you are printing, for example, 100 A 100 times, that will happen first, and then B 100 times will happen next, and then printing 100 characters will happen next in a procedural program where you are not using threads. So you can actually try that. You can try to create a program which prints A 100 times, B 100 times, and 100 1 to 100, and you'll see they will actually always run sequentially. One will finish, second will finish, then the third will run. But when you use thread, they will run simultaneously. They will actually run together. So you can see here in this program, this is printing A, this one is printing B, this one printing numbers, and you can see here everything is all over the place. A's are there, B's are, numbers are there. There's a mix-up of everything, So you have numbers, and then you have A's, numbers, you have B's, numbers, all A's, all numbers, all B's, meaning this sometimes this task is running, sometimes this task is running, sometimes this task is running. So they are all running randomly at different times because they are actually running simultaneously, and we are seeing the output here because every task is showing the output using the system.out.print. So when it runs, it prints, when it runs, it prints. That's what it does here. So this is an example of a simple multi-threaded program, and how we actually achieve concurrency. So that is what we mean by in a nutshell concurrency programming, you know. Of course there will be more details in order to do that. Okay, so if you don't see the effect of these threads, for example, if you test this on your system and you're not seeing anything, that means you are not able to show it effectively in your system. You can change these things by printing it more times, like instead of 100 times, try to print it 1,000 times or 10,000 times. Then you will see really effectively the changes. As you can see, 3 tasks running simultaneously. Okay, so here's an important note about run method. The run method in a task is specify how to perform a task. This method is automatically invoked by the Java virtual machine. You should not invoke it. You are not allowed to run directly. You can invoke it by thread. So invoking run method directly merely executes this method in the same thread. So it's the same as running the thread. So just run the thread and there you have a new process created. Okay, if you look at a graphical user interface example, in this case, for example, you see you have a graphical example of a particle, a small particle drawing. You can say a particle is like a dot, and what it does is it creates a square wherever it is. So in this particle class, you have a constructor that creates a particle provided given xy coordinates. So if you say there's a particle here, this is where it exists. Particle here, this is where it exists. So it has xy coordinates, and then it has a random value where it exists. So any specific given value is just going to be in a random position. So and it doesn't change. The position doesn't change for a given specific value, specific particle. Okay, so you have to create a new particle. So it's continuously creating new particles simultaneously, and this will be more vivid when you show it in the NetBeans. So you can run this in NetBeans. I'll show you an example here after this. Okay, so you have this synchronized method. So slowly you will come to know these things. Synchronized is a word we use here. You can use the keyword synchronize to synchronize the method so that only one thread can access the method at the same time. So meaning if you move this at the same time, that doesn't make any sense, because two threads can't move the point at the same time. It can move only once. It can't move simultaneously, you know. So a point can only move once. So either one of the processes can move it, which is why you have to synchronize it. So you have to synchronize it, which means when one thread is moving the particle, the others cannot access it. So it will just move to a random location. Again, you can see here there is a random number, and then it just moves by subtracting 5 and 10 like this from a location. So this is moving it to a new location, and then every time it will just move to a new location, move to a new location. Originally it is located at this random location, and then it keeps on moving. And whenever it's of course it's not moving in this program, it's a method that will make it move. Okay, then you have a draw method, which is going to draw a little rectangle or a little square, you can say, because you can see here width and height are the same. So this is a little square. So this square will be drawn wherever that point appears, and what it does is it actually draws that on a specific location. Okay, so that is what the particle class is about. Now how do you draw that particle? Of course, I guess there is something else that is missing here. Okay, so let's see this in the NetBeans. The particle class is shown here. The other parts of the particle class is not shown here, which I'm going to show you in NetBeans. So here in NetBeans you can see we have the particle class. The particle class is just a basic particle class having those things that you just saw on the PowerPoint slide. And then we have a canvas here where we draw the particle. So the canvas is just a function of the class where you have an array of particles, and when you are given the array of particles, you are just going to plot them onto the canvas. That's the idea here. Of course, this is just little graphics manipulations, so you don't have to know exactly much about graphics. You just have to follow this example, type out this example yourself into NetBeans and see if it works for you. So this is an example of a small canvas where you have class, partial canvas, extend canvas, and remember to import these classes to make this work. And after you have imported them, even here in the particle class there are some imports, and of course if you are using NetBeans, you can just use Ctrl Shift I. It will automatically import these classes. if you are using your own code editor or something like Visual Studio Code or Eclipse, they may also have automatic imports, but you may actually have to have these imports manually inserted as well if it doesn't work. So you have this canvas class here where you are drawing those particles, and it does nothing, it just draws them wherever it is given. So see here, the paint method is where actually drawing happens. So you are saying, okay, draw that specific particle, draw that particle. So you are given a particle and you just draw it. Okay, that's the job of your canvas class. Canvas class have a paint method where it will paint dot on the canvas, and it has this getter and a setter, meaning all the particles can be identified, all the particles can be set. So setters and getters, something you are familiar with, of course. So setting all the particles and getting all the particles, so which means someone else will set them, right? So which is the purpose of this specific class here. So this is a small applet. So what you have to do is, when you create the J applet here in NetBeans, for example, you actually have to go to thread here and create actually you can click your package name, create a new J applet. See here, if J applet doesn't appear here, then you can go to other and you can go to next. From here, fine, applet or J applet name is fine, and next, and then you are able to add this class, which will generate for you this line extends J applet, and it will import for you this. Okay, if it doesn't, you can just import it, Control Shift I, it will import for you. So that is the example of a graphical interface class where multi-threading is happening. So what is happening is, you are creating an array of threads, you are creating a canvas where you can draw, and then you are giving this value of 100, which is what the canvas is asking as a size of the canvas. So it's actually width and height, meaning how big is that canvas. And into the canvas, okay, of course this is just a init method of a applet class, meaning when you run the class, this is going to start. And then you have this you have this add method, add canvas method, which is going to add the canvas into your see, this canvas that you created here is going to add this canvas into your applet. This means this dot add actually. Of course, you don't have to do this amount of programming, it's just showing an example. So you should just understand manipulating graphic and creating canvases and drawing rectangles is not something you have to do in multi-threading. It's just showing an example of what happens when you draw graphical user interface with multi-threads. So you can see here we have this run method inside applet, which is typical of applets. Applets have a run method. So in this case, rather it's not the run method actually. It is actually the run method of the runnable object. Yeah. Okay, sorry about that. So this is actually called an inner class, right? So you have here a thread method that returns a thread, and this method creates a thread and returns a thread. Okay, you can see here, see, it returns a thread, and what it does is it returns this run loop, and this run loop is inserted into thread, just like what you saw in the PowerPoint slide. The thread needs an object which implements runnable. So either you can implement runnable, or you can assign a runnable object into the item. In this case, that is what is happening. So you are saying here, okay, make a new thread, and to do that you created a new runnable object inside this method, and this method created a runnable object by assigning into the runnable object this run method, and this is the most important part of the task, you know. So what does it do? It actually infinitely keeps on drawing what is P particle. So it infinitely keeps on drawing the particle and then paints it, and then it waits for 100 milliseconds and it does it again, you know. So so this is the actual starting of the application, meaning because this is an applet will start at the start. So what happens is, it will create 10 particles, you know. In this case, let's just create a 50 particles, you know. It will be more vivid and visual. So you create 50 particles, and then you send the 50 particles into the canvas. You see, you set them, these are my particles. Then you also create 50 threads, because every particle is going to have its own movement. Move it, draw it, move it, draw it, like that it goes going. Alright, so that's how it does. So there is, you are making a thread, and then you are starting that thread. So this is the most important part of a thread. So multi-threading is about creating multiple threads. So it will continuously create those threads, and they are all going to run at the same time. and they will do this. Let's have a look. When you run this program, of course you have to right click the applet, right click, run this file, and then it will run. See here, oh, it's too big because 50 particles. See, randomly they have been drawn at different places. So they started randomly at a position, and now you can see here they are being drawn. Yeah, so sometimes they might go off the screen, so it doesn't appear in this part, so might have to take actually negative values. So initially you can see where they are. See, they might even come here. Yeah, let me run it again. So yeah, see, they're starting here and minus values, therefore they are moving to the left. Okay. Yeah. Okay, so there's an example of simultaneous drawing of 50 particles. So you have to make sure you read this, okay, because I want you to type these things into your own NetBeans and test them out. So you pause the videos for typing these things and make sure you follow the video and test them out yourself, because the best way to learn these things is actually typing them, you know. So there is no shortcut to learn these things. Make sure you actually read through and type them yourself. Yeah, let's get back to the PowerPoint and finish this off. Right, okay, so there's a GUI example here. Now the thread class itself has several things. Here you can see these are the thread class methods. It can have methods where you can check, is the thread alive? You can set a priority for it. You can join a thread, you can sleep a thread, you can yield a thread or interrupt a thread, and this is what it does. Okay, so since the thread class implements the runnable object, you could define a class that extends the thread and implements the run method inside there as well. Okay, then create an object from the class to start the start method. This is a little bit vague. You'll see this only when you see a real example actually. Okay, yield method. What does the yield method do? So I have here an example of all these methods listed here. I want to just go through them. Basically, a yield method is temporarily release time for other threads. So every time a number is printed, like this case here, every time a number is printed, the thread of print 100 task is yielded. So if of course this appears in the print 100 task run method, so each number is followed by some characters. So what you do is you actually print a number and then you yield, okay, like that it goes on. So a thread may never get a chance to run if there is always higher priority thread running, or the same priority thread that never yields. So if the thread never yields because of its high priority, then other threads may not actually run. So this situation is known as contention or starvation. To avoid contention, the thread with higher priority must periodically invoke sleep or yield method. So actually this is an important thing for threads to do. They should thread or they should yield or sleep sometimes to give others time. Let's see, for example, sleep has milliseconds inside it, so you give the number of seconds and it will sleep for this number of x number of milliseconds, and if it is more, it will sleep for that long. In this specific example, you have this run method of the print 100 tasks. So if you have printed more than 100, more than 50, if you are here at the 50th value, what happens is every time a number greater than 50 is printed, the thread of print 100 task is put to sleep for 1 millisecond. You know, it will sleep for 1 millisecond and then continues. You can actually make it sleep for 10 seconds, for example, and see the effect. So you will actually do this run method in the print 100 tasks. Okay, so class numbers run method, print num methods run method is shown here. Okay, join method. What happens in the join method? You can use the join method to force one thread to wait for another thread to finish. For example, a new thread 4 is created and it prints character C 40 times. You can see here in the run method you are creating a new thread. So in the run method itself you are creating a new thread, and then the number from 50 to 100 are printed after thread 4 is finished. See, you have a if condition here. You have started the thread 4, it's continuing, and then at some point of time you are checking whether I have printed 50 numbers or not. If you have done 50 numbers, then you will just pause and say thread 4.join, meaning okay, I'll stop here until this guy finish. So you have if and a semicolon. So this will execute until 4 is finished, then you will continue the rest of the program. Yeah, So that is what is join method, and of course I want you to do this and test it yourself. That's your tutorial for these classes. For the first week you will be running the programs here and testing out yourself. How do you give priorities? Okay, so a thread can have priority. You can just include a thread and dot set operator. So there's a member function called set priority in the thread class. Yeah, you can give predefined values like thread class dot max underscore priority. So this comes from the thread class, so they are predefined. For example, minimum priority, normal priority, and maximum priority are 1, 5, 10 respectively. So maximum priority is 10. So the priority of the main thread is thread dot normal priority, which is 5, for example. So when you create a thread, you can actually give it a priority. And the important about the priority is the JVM always picks up the currently runnable thread with the highest priority. A lower priority thread can run only when no higher priority threads are running. If all runnable threads have equal priorities, each is assigned an equal portion of the CPU time in a circular queue. This is called a round robin scheduling. So if you ask what is round robin scheduling, you should mention about the CPU time in terms of circular queue. Okay. In this case, what happens is, because you have given a max priority which is 10, the thread of print 100 task will be finished first, because the task thread 3 is about printing number of number 1 to 100. So it will do first. So you try to modify and see the results. Okay, so threads can have states. So I think this is the last slide. So threads can have states. So you have to remember this diagram. You have to draw this a few times yourself. When you create a new thread, you can start it and then it's ready. And the thread could yield. Once the time runs out, it can run again, and if it yields, it will run again, like that. During the running phase, it could be asked to join, meaning it will wait, and when it is waiting, it is kind of stopped or paused, and then it will resume. And then sleeping does the same thing, but then again it will wait for timeout, similar to join actually. So the difference is, wait for target to finish is what the join does. Sleep means you will sleep only for x number of milliseconds, and then you will wait to be notified, for example by using wait method, and in that case you will wait until you are told to continue, okay, until you are signaled. Yeah, so this diagram you must really know very well, and then there is a finished state where the task is completed and what's supposed to do. Right, and next next classes, we are actually going to study about objects and concurrency, which is going to be our next section. So you can see here these sections are quite heavy and lengthy, but the reason why I have recorded them is so that I don't bore you in the online sessions, and let you watch it in your own time, and later on also you can come back and watch it, and that way you will have a good reminder and good revision as well. Okay guys, thank you very much for listening. That's the first session. See you in the next session, where we will talk more about objects and concurrency and other things. Alright, thank you very much. I'll just stop recording this.